So my presentation is on Connect security. This is a very important topic because it's very important to our customers who are paying you and paying us lots of money to use our products. We want to look after them. It's also important because it's hard and complicated, and in the Connect team we've put a lot of effort into taking care of a lot of the hardness and a lot of the difficulties for you. So my name is Peter Brownlow. I'm a senior Java developer. I work on the Connect team. This is a topic that is very close to my heart. I've been deeply involved with gathering the requirements and doing the designs and writing the code for the Connect security framework. So this is really important to me, and I'm really enthusiastic about it. And I want you guys to be enthusiastic as well. So first, some inspiring statistics. We have about 3,500 unique installs of Connect add-ons from the marketplace already. This is phenomenal because Connect has only been out in its post 1.0 form for a couple of months. So well done, guys. This is fantastic. However, this number is a lot bigger. This is the same statistic for in-process plugins. So these are the old P2 plugins. That's the old world. Connect is the new world. We want to grow more than 500 times in order to make Connect installations overtake in-process plugins and then just keep going on into the future. So 500 times and then more. This is important to everybody in this room because we're all selling software. The more growth we have, the more revenue we all have, and we're all in this together. The more that Connect grows, the more that OnDemand grows, and vice versa. And as part of this story about growth, there's this natural tension between security and usability. The more secure you make a system, the less usable it is, and vice versa. Passwords are an excellent example of this. It's obviously tedious to type in this arbitrary, hard-to-remember stream of characters before you can do anything, but it performs a useful function of preventing random people from taking over your account. I'll come back. Just keep in mind this theme of growth during my presentation. This is really what Connect Security is all about for you guys as vendors. We want to help you to grow. Also, don't screw up the customer. This is really important to us at Atlassian. We genuinely want to protect the data of our customers, and we want to make it easy for you guys as vendors to do the same. This is the structure of my presentation. First of all, authentication. Who said that? Then authorization. Can you do that? Third, some sneak peeks, which will hopefully be interesting to you. And then at the end, we should have about 5 minutes for questions. And there are always security-related questions. Now, I have a couple of exclusions from this talk. I'm not talking about in-browser security very much. I've only got half an hour. It would overlap a lot with the presentation after me, which is about front-end development. I'm not covering privacy or copyright, things like that. I'm also not covering non-repudiation and things like audit trails. These topics are part of security, but I've only got half an hour, and I want to cover the most important things, the areas where Connect does the most work and gives you the most bang for buck right out of the box. So first, authentication. Who said that? It's essentially like this situation. Imagine some dodgy character is trying to claim to be someone so that they can do something. In this case, this guy wants to buy alcohol, and he's claiming that his name is McLovin. Do you really believe this guy? Do you also believe he's 33 years old? Maybe not. But in real life, it's actually even worse, because McLovin is sending you a letter. You can't even physically see him in front of you. So here's the first of 6 brain teasers where I want you to put yourselves in our shoes. These are the sorts of problems that we face trying to implement the Connect security model. So you receive this letter purportedly from McLovin. How can you tell? Well, in a physical letter, the sender has written their name up here. So that's great. It tells you who they are, but it's unverified. Anybody could write that. Well, look at this, though. There's handwriting. It's kind of like a signature. It's hard to fake, and if you've dealt with this person before, you know that that's McLovin's handwriting. So now you can tell, yes, it really was from McLovin. Second brain teaser. Was the letter tampered with? Well, look at that on the right-hand side there. It looks like it was. Somebody has torn it open. It's visually apparent. The tampering looks wrong. And it would be great if in Connect, where we're sending and receiving HTTP requests, which are a bit like letters, it would be great if the tampering were evident like that. You could just look at it and see. I'll come back to that later. Keep that in mind. So hopefully it's going to look wrong. Was the letter resent? Maybe someone is attacking you by capturing McLaughlin's letter, which is a request for money, and sending it to you at a time of their choosing 2 years later on when it's bad for you. How can you protect against this with a real letter? Well, there's a postmark. It's physically stamped and it says it was processed on this date. So if the date was too long ago, you know that it's highly suspicious. So we have all these problems and similar solutions in Connect Security. Now, I'm now going to segue into our actual implementation. I'm going to talk about it for a little while, and then I'm going to join these two topics back up again, the implementation and the letter analogy. So we use JSON Web Tokens. This is a protocol that you can find out there on the web. It wasn't invented in Atlassian. And each token is a string. You can send it along with the request, and it helps to verify the identity of the sender and that the request wasn't tampered with and that it wasn't replayed at a later date. So you can just include it as a parameter on an HTTP request. You can also put it in a header. We've chosen to allow both. So for example, this could be an iframe URL, and on the end, there's a JWT parameter, and we read that in Connect. It could also be there as an authorization HTTP header. Now, this JSON Web Token is a string, but what does it look like? Well, it's structured. It has a header, and then some claims in the middle, and then a signature at the end. Now, the header and the claims are JSON, so this should be very easy for everybody here to parse, both in their heads and in their code. The header's not very interesting. It's very brief. It just says the type of this message is it's JWT, and it uses a particular cryptographic algorithm. The claims in the middle is where the real meat is. This is the interesting stuff. So it says, oh, this is the issuer, and it expires at this time. Don't consider it valid after this time. It also has a bunch of other standard claims that are part of the JWT protocol. And the JWT protocol allows you to add custom claims. And we've done that. We've added one particular custom claim, which I'll come to in a minute. At the end, there's a cryptographic signature. This is computed over the preceding two parts. It's very hard to fake. You'd have to actually know someone's private key or their shared secret. So if the signature matches the rest of the token, then you know it's good. It's extremely hard to fake. Then in the end, the whole thing is base 64 encoded, so you get jumble of letters and numbers, and then a dot, jumble of letters and numbers, dot, signature. So it's got three parts. So let's bring it back to the analogy. So you remember in the real letter, you got the sender claim. You have the handwriting, which is like a signature, very hard to fake. You've got the tamper evidence on the right-hand side. You can see someone's torn it open. And you've got the postmark. Well, in JWT, the sender is the issuer claim. Very simple, just plain text says this is who I am. The physical signature on the letter is like the cryptographic signature in JWT. Very hard to fake. So if you change the content of the JWT token, the signature looks wrong. Another thing that makes things look wrong if they've been tampered with is we have a custom claim called the query hash claim, which is a hash of the parts of the URL we do not expect to change due to routing rules. So if somebody adds, removes, or edits a query parameter, for example, then the query hash will look wrong. And if you manipulate the query hash without being the person who genuinely is issuing this token, then the signature will look wrong. Oops. So that's the end of authentication. So now we know who said that. It really was McLaughlin. If somebody else had sent it, it would have been tamper evident. We'd know. Now authorization. Or, can you do that? That's a little bit like this scenario here. It's a very high security area, obviously, as you can tell. And McLaughlin's going in there because he's just got a job as an intern. So he's genuinely allowed to do some things, but probably not everything, because he's not exactly the most senior member of staff. So, second three brain teasers. There are aliens in Area 51. Who's allowed to see them? Obviously not everybody. These two characters show up. You've got some Air Force general-looking person and McLaughlin, the intern. Who do you allow in? Well, one way of doing this is to divide them into two groups, statically, generals and interns. And then generals are allowed to see the aliens, interns aren't. This is very easy to do because you can tell which one is which. It's a very fast decision to make, and it's very easy to explain to people. Our implementation of this in Connect are the scopes. So read, write, delete, project admin or space admin, and admin. They're declared in the descriptor. So every time an add-on is published and then installed in a bunch of instances, they're the same scopes everywhere. And every time this add-on tries to take an action, we can tell, is this a read action? Is it a write action? If it's a write action coming from an add-on that is supposed to be read-only, then we know not to allow it. If it's a write action from an add-on that is allowed to perform write actions, then we know to allow it straight away, very quick. Here's how they look in real life. This is from a real add-on that I've made. The line in the middle there is declaring the scopes. So this add-on can both read and write. Very easy. Second brain teaser. How did that guy get in here? How to avoid security surprise. A security surprise is when McLovin, the intern, has gone somewhere and he's genuinely allowed to be there. There's no security breach. But the general doesn't really trust the look on McLovin's face. It looks like a suspicious character to him. He's not. But the general's surprised. And the general is a very important person. In real life, this would be like a customer. You don't want your customers to be upset or afraid. You want them to trust your software. So how can you avoid this surprise? You make McLovin carry a pass. The general can see it. Security surprise goes away and is replaced by a happy green tick. The general knows that everything's okay. And the general only knows this because it's actually very visible. So what's our implementation in Connect? Well, we make it visible. We display scopes to an administrator when they're installing your add-on. So then later on, after they've seen this screen, they're not surprised. You see that section in the middle there? It says in very plain language that this add-on can do everything up to and including deleting Jira data. So then when the add-on immediately starts maybe deleting some Jira data, the administrator's not surprised. Third, personal access can change arbitrarily. This is actually a really tricky problem and a big subject for the Connect security model. So let's say you've got this one particular intern here, and for some reason, the administrator's decided that he's going to give more access to McLovin than to the other interns. Now you can't use your, is this person an intern or a general check? You've got to do something personal. And you've got to do this every single time this person tries to do something, because this access could get taken away at any moment. So how do you accurately allow access? You can't just block it. Remember, the customer here really wants this person to be able to take these actions. It's important to them, and it's important that this is done very quickly and smoothly and efficiently. They don't want any holdups. Well, our implementation for this in Connect is add-on user permissions. So when you install an add-on, it's assigned a user. It's a different user per add-on, so they can be permissioned individually. And then administrators can permission these add-on users much like they would normal users. Then when a server-to-server request comes in from an add-on to the host product, we treat it as coming from this add-on user. That's very important because we have hard requirements both internally in some of our systems at Atlassian and from customers saying that, yeah, no add-on is allowed to access this particular piece of data because it is particularly super sensitive. Most of it is fine, but you cannot install any add-ons in my system unless I can prevent any of them from accessing this exact thing. Or this other thing is supposed to be read-only. No one can write to it. And normally, this particular add-on that I love can write, but I just want to protect this one little bit of data. And if I can't protect this bit of data, I'm not installing any add-ons. Obviously, we want all of these administrators to install lots of add-ons. It's good for growth. It's good for everyone in this room. So we need to allow them to arbitrarily protect one little piece of data. Treating requests as coming from a particular add-on user allows us to do this. Administrators already know a lot about permissioning users. They can tweak groups. They can tweak settings on individual pages and issues and projects. And we didn't need to build a whole bunch of new UI to make this happen. So this is a good example of the trade-off between security and usability not being very hard, actually. It's good usability because administrators already know how to permission users. It's good security because they can permission add-ons individually now. Here's how it looks in real life. You can see this is one of our user management screens. The list of users and the ones circled by the red box are actually add-on users. So now you can come in here and you can click on them, and you can change their permissions, you can add them to groups, you can remove them from groups, exactly as you would the top one, atom ordinary user who's a human being. This leads to this situation, where the actions that an add-on can perform are the intersection of what's allowed by their static scopes. Remember, they're the same on every single install. And the user permissions. Remember, they're different on every single instance. With one detail here, the user is not always the same user. I said server-to-server communications for the add-on user. If someone is in the browser clicking on things, then we use the browser user. Ultimately, we're going to marry these up, but keep that in mind for now. It's actually very important. In the browser, it's the browser user. Server-to-server is the add-on user. So that's the end of authentication and authorization. We now know who said that. It was McLovin. And who is he allowed to do that? Yeah, McLovin's allowed to do that. Now some sneak peeks. Hopefully this is interesting to you. Sort of whet your appetite a little bit for security features that are coming up. I know all three of these have been asked for by various people at different times. These are ideas in motion. They're not yet implemented. Don't take this as being exactly the way that things will end up. Hopefully this is interesting to you. So first off, maybe more custom JWT claims. You remember we've got the query hash claim, which protects the contents of the URL. Someone tampers with the URL, it's evident in the query hash. Someone tampers with the query hash, it's evident in the signature. So it's very hard to do this. You basically just can't tamper with it. But this leaves the headers and the body unprotected. So the obvious solution there, we're going to add another header hash claim and a body hash claim. JWT expiry improvements. These are things that some of you have asked about recently a lot. It's to solve this particular problem. So the user loads a page. The page has a link in it. That link has a JWT token in it. That token has a particular expiry. The reason it has the expiry is to prevent someone from capturing it and just replaying it in 5 years' time as some sort of replay attack. But the user loads the page now and then goes to lunch. They come back after a very long time. They click the link and boom. It's expired. They get rejected. So hey, very secure. We prevented a replay attack, but not super usable because this is actually a genuine user. They're actually logged in. They're allowed to click this link. It's just that it expired. So what we want to make happen is when you click the link, as a genuine user who's allowed to do this, it doesn't actually expire. And we might do this using some sort of JavaScript API so that you can call this and it somehow gets a new token from the server. Three-legged auth, the ability to act as a particular human user. This would be a super powerful feature because that would allow you to make your add-on leave a comment or edit a page, transition an issue, and have it appear in the UI and to everyone else that the human user actually did this themselves. This could be very useful. Imagine you have an add-on that automates mundane tasks. Imagine you have an add-on that funnels data from another system, and you have the same person is a user in both. You want this to, their actions in, say, Jira or Confluence or maybe Bitbucket to appear to have been taken by this person. You can imagine a Bitbucket and Jira integration piece where, let's say, you make a pull request in Bitbucket and it automatically transitions your issue from in progress to under review. And then when you merge, it transitions it from under review to done. Very useful. And it would make sense for this transitioning to appear to have been done by the human user. But this could also be kind of scary to users. Imagine they don't actually log into Jira for a while and there are all these comments left by them. We don't want to scare people. We don't want to have a security surprise. We want to warn people up front. So it'll probably be authorized by users in some fashion. This would also be for server-to-server calls. We believe that in the UI, if the user is actually physically clicking on something and saying, do this now, then it is natural for those actions to appear to have been done by that user. Of course, if you have an add-on that relies on being able to act on behalf of a user, you want to know whether or not you can do this before you actually try to do it, and then you get rejected by the host product because they haven't authorized it. So how would you know? Well, we would very likely include some query parameters, and we would also very likely include a REST resource that you could call in order to get a yes/no answer for, am I authorized to do this? So to recap, authentication. Who said that? Our implementation uses JSON Web Tokens. They have claims, including the issuer claim and the query hash claim. The issuer says who sent this message. The query hash makes tampering with the URL evident. JWT tokens also have a cryptographic signature, which is very, very, very hard to fake. So then that means if the signature matches the token, then you can trust the token was genuinely constructed by the sender. Authorization. Can you do that? So now I know who you are you allowed to take this particular action? Well, our implementation uses scopes, which are static, which is very convenient. You as add-on vendors can just write up one descriptor that is used in all installs. You don't need to worry about the differences between this instance and that instance. It also allows us to display these scopes on installation to prevent the security surprise of an administrator not knowing that, for example, this add-on is going to delete data. But those are static. They can't take into account the differences between instances. So we have user permissions, which are dynamic. These will be the add-on user for server-to-server communications, the browser user for in-browser requests. That's the end of the talk. Now it's time for some questions. If you have... This clicker is super, super sensitive. There we go. Okay, I'm just going to put it down now. Okay, so this is URL here, go.atlassian.com/ac-security. That'll take you directly to our security docs. You can read about everything I've said in this presentation and more there. We've got loads of examples, lots of code that you can copy and paste. Now, I think we have a few minutes left. Are there any security questions? Come on, guys. There are already a couple of what-ifs. Come on.
Hi. How do you exchange the secret between the client and the server?
On installation. So the first time you are installed in a particular instance, you receive this call. You have to respond with an OK response. If you don't, the install does not proceed. The payload for this call includes a shared secret. It's over HTTPS, so there should be no eavesdropping. This does leave the question of then how can you really know that this is something.atlassian.com or something like that? Well, you can't, but that's not a huge problem. You trust that if this is the first time you've received it, it's real. If someone else comes in later on saying, hey, I'm really this server, you don't trust it. It seems unlikely that someone's ever going to actually try to pretend to be extranet.atlassian.com. But if they do, you would be able to tell that it's not real.
Are there any features protecting against evil code in the plugin?
Generally, if an add-on wants to do something evil and everything is technically correct, so they've said, hey, I want to delete data, say, and an administrator has said, yes, you can delete data, I trust you, and then evil code in the add-on deletes data that it's not supposed to delete, there's no particular protection against that. If someone actually installs an add-on and says, yes, you can delete my data, that add-on can delete their data. And that covers accidental deletions as well. There might just be a bug in the code that deletes the wrong page, for example. It's buyer beware, really. There are protections against sort of malicious attacks from outside, like pretending to be an add-on who's not installed, trying to take over someone else's add-on, trying to do nasty things in the browser to get inside someone else's iframe. Protected against a lot of those things. But if it's a genuinely installed, genuinely created add-on, no. You'd have to actually get through Marketplace as well. Someone would have to look at it and try it out a little bit. So hopefully evil add-ons wouldn't actually get through. But I guess we're kind of mostly assuming that people in this room, when they're creating an add-on and they're putting in the effort to post it up on Marketplace, and they're creating marketing assets, and they're writing a lot of code, and they're taking money from people, their main interest is selling more copies of the add-on. And if you make an evil add-on, obviously that's going to come to a grinding halt really fast.
Okay, we've got time for one more question.
So does the three-leg authentication also provides features like, login using your Twitter account, your Facebook? So I would like to say login using your OnDemand account. So really building a separate application which sits next to, for example, Confluence, and I can really log in on my other platform as the OnDemand user and, of course, then act as this user in Confluence.
it would allow you to do that. Yes, that's not its real purpose. Purpose is more power and more convenience, but there'll be an implementation detail. You could actually have another system that, when you perform actions in this other system, it then goes and posts things for you. We're not actually trying to create an identity verification service here. That's not the goal of three-legged Auth. It's more power and usability inside our products. All right, I think that's it. All right. Up next, Chris Whittington.
Thank you, Peter. Thank you.